So when we deal with special right triangles, okay, they actually come from somewhere. It wasn't just some crazy mathematician decided this is how it is and this is how it works. It actually comes from somewhere. Like for instance, up here in the warm-up, normally if I'm looking for the side of a right triangle and I know two of the other sides, I use the Pythagorean Theorem. Okay, I use good old a squared plus b squared equals c squared, knowing that c squared is the hypotenuse. So, because I know where my sides are, and again, I'm not worrying so much with these about opposite and adjacent and stuff like that, but I know this is my hypotenuse. So I'm like, okay, if I was going to solve this, it would be x squared plus 4 squared, my two legs, equals the square of my hypotenuse. And I... Correct. Yeah, and the question was, does it matter on these which one is which? Like if I put 4 squared plus x squared or something, it doesn't matter a bit, as long as I get the hypotenuse part right. So I'd go ahead and I'd work this out, minus my 16 over, to solve for my x squared. And here would be the part that would get interesting, because I know a lot of you would go to the calculator and you'd be like, okay, I get here, I know the opposite of squared is square root, and you'd put down the decimal value, which would be like 6.9 something something something. But we don't want to do that when we're dealing with these. So we're going to kind of do a rewind back to something we've done earlier in the year, which is we're going to break this radical down. So again, back to, I've got to know my perfect squares. Now if I have to use my factoring sheet that has the perfect squares on, remind me, that's okay. But I need two numbers that multiply to 48, one of them hopefully being the largest perfect square that I can think of that would be a factor. Nice, okay. And again, if that's something you struggle with, you may have to have a list that you write down and keep handy so you can kind of think about this a little bit. But right, 16 and 3 would work for this because I really want the biggest one. And so the square root of 16 is 4. Okay, not the square root of 4, just 4, because it's a perfect square. It breaks down clean. But the 3 isn't. So this side of my right triangle would be 4 square root of 3. And we're going to make a connection with that in just a minute. I'm just kind of letting you see how this works. So that's this one. So when I move over to number 2, okay, we're going to use the same concept, except this time I'm looking my hypotenuse, always opposite my right angles, on the other side. So this time I have 2 legs. So I'm going to have 3 squared plus 3 squared equals x squared. And I go ahead and I work that out. And again, I notice, oh crap, 18's not a perfect square. I'm going to have to figure out this breakdown thing again. So this time, right. When I look at it, I'm like, oh, 9. Okay, 9 goes into 18. So 9 and 2. And the square root of 9 comes out nice. It's 3. The 2, not so much. So I'd have 3. Square root of 2 is my side. You're kind of doing a very nice job of introing to something that we're going to deal with. Are we going to have to, I think you're wondering, are we going to have to rationalize the denominator? Yes. And that's coming. So for now, though, it just kind of lets us see, okay, here's where this comes from. So now that leads us into today's lesson, which is on special right triangles. Okay? Our 30, 60, 90 and our 45, 45, 90. There's a pattern that develops here where I don't necessarily have to go through and do the Pythagorean theorem, especially if I'm only given one side, let's say. So here's how this works. My 30-degree angle's side measure is always going to be S. We call this the short side because when you're looking at a right triangle, the smallest angle has the shortest side. My angle opposite of 60 is called my long leg, or my long side, and it's always whatever this value is times the square root of 3. And then my hypotenuse is always just double my shortest side when I'm doing a 30, 60, 90. Now when I'm doing a 45, 45, 90, it's a little bit different. Because here, my two sides will always be the same. It's an isosceles triangle. But then the hypotenuse will always be that side times the square root of 2. So a couple of things to keep in mind, because this is about patterns. Let's say I want to find a side, and I'm given the hypotenuse, and that's going to happen. Another way I can look at this is I can take the hypotenuse and divide it by the square root of 2. And that's actually what was just asked about, bless you, in that that's what I'm going to have to rationalize my denominator, because I can't have a square root of 2 down there, but at least it gives me a setup. Okay? Or if I'm trying to find my hypotenuse, okay, that's going to be my leg times the square root of 2. So all of this stuff interconnects. It all has a pattern that develops that once I start to get the feel for that pattern, these can really go fast and I'm not having to do as much work. And isn't that really the goal in any of this stuff, is to not have to do as much work? So here's how this actually is going to work for us. Let's scooch this a little. So find the missing lengths for each 45, 45, 90. Okay. So when I'm looking at my pattern, side, side, and when I try to find the hypotenuse, it's just the side times the square root of 2. So all I have to do is write 7 square root of 2. Now, could I, and I'm going to just do this quickly to show you how much work you're saving, could I do the Pythagorean theorem? Sure. But I'd have to do all that stuff we did up above. I'd have to do all of this, add the squares together, take the square root, break it down. I couldn't agree more. I don't want to do all of this every single time. That's not what I want to be dealing with. By understanding the pattern, that was like 2 seconds. That was like more than 2 seconds. And so I've got to start to learn, like we've mentioned earlier in the year, knowing your perfect squares. Well, now I need to understand these patterns. I need to work on getting the hang of these. For 45, 45, 90, it absolutely will be. Okay? Now, the one situation that gets a little trickier is when we get into a situation like letter B. Because now I have the hypotenuse, okay, which I know by remembering my pattern basically is x times the square root of 2. You're like, okay, so what's that mean? Well, what that means is to figure out what this value is, and I guess I could call this y. I'd say, ooh, it's 5 times the square root of 2 divided by the square root of 2. Because if I'm trying to figure out what one side is, I've got to get that out of there. Now, this time it worked out nice for me. Because these are the same, I can just cancel them out and say that each of my sides is just 5. But we're going to talk about a couple of situations. We're going to do a couple of these on the worksheet in a minute where it doesn't quite play out that nicely. But we're going to make sure that we've got an example to work with. So when you're... Well, and it basically is just taking whatever side you have and kind of making an equation out of it. Because if I didn't remember the pattern, what I can do, and what I actually did here, was I said, okay, this side of my triangle equals this. So if s square root of 2 equals 5 square root of 2, And I want to know how long a side is, which is my y value. It is. That's what we actually just did, right, because the 2's canceled out, right. That's on that particular problem, absolutely. If you see a hypotenuse times the square root of 2, you can just write the number down. But like I'm going to show you in a bit, it won't turn out that nice every single time. Same thing with my 30, 60, 90. When I'm looking at these, there's a couple of ways I could do it. Now, here's one thing I'm a fan of, especially if you're trying to learn this pattern. What I'm going to do is I'm going to label each of the sides as I'm doing this. So, for instance, my hypotenuse is 2 times the side. Okay. My short side, my side that's opposite my 30, is just S. And my long leg is S square root of 3. And you're like, okay, now why would you do all of that? Because now I can visually see, okay, what do I know? I know that S equals 4. Okay, so if S equals 4, I'm just going to plug 4 in here. This is 4 square root of 3. I'm done. I like this. If S is 4 and this is 2S, this is just 2 times 4. Or 8. That's my hypotenuse. I'm done. But that only works if I know those values that I've written in red. So that's why I've got to understand the pattern. And if during the worksheet today you need to have this note sheet out and be staring at those patterns the whole time and writing them, that's fine, but you've got to get to know them. And I'm going to do the same thing on the next one. Okay, short side, hypotenuse. Yes, I'd rather leave it that way and not go to a decimal or anything like that, absolutely, because that gives us an exact answer that way. So here, okay, here's the first time this is going to get a little more complex. Because this time, here's the one value that I have. So I know that S square root of 3, and if you'd rather use X because S's and 5's can start to look a lot alike, that's fine. So I get here, and I go, okay, I want to know what S is. Well, to get S alone, I've got to divide by the square root of 3. You're like, okay. Well, here's my dilemma. You get a decimal, which we don't like, and we also have a radical in the denominator, which we cannot do. That's mathematically incorrect. So this is where we're going to do what we've done before, which is called rationalizing the denominator, which basically means whatever that radical is in the denominator, we're going to multiply the numerator and denominator by it. So up top, the 12's not under a radical, so I can't multiply 12 and 3 together. They're not like. But down below, those are both under a radical. 3 times 3 is 9, and the square root of 9 is 3. We've eliminated the radical in the denominator, which is goal 1. And it's always going to be whatever the radical is that's there, which is going to be 3 in a 30, 60, 90. But my one last thing to check. Notice the numbers that are not in radical jail. If that's reducible, you need to do that. 12 divided by 3 is 4. Square root of 3. So you're like, okay, what did that tell me? It tells me what the S value is. So now I know what this is. This is 4 square root of 3. It helps me with A, because this is 2S, or if you used X, 2X. 2 times that, which would be 8 square root of 3. And I'll be honest, there's even a pattern to these. I'll show you as we do a few more, but all of this is patterns, and once you get the pattern, it really does go quickly. I'll get to a point where I don't even need to do this. We're not there yet, though. We'll get there, though. So then these last couple, and then we're going to do some on the worksheet because I want to make sure we've got this. Okay, find the missing angle. Ooh. I have to be able to recognize some things. As soon as I see a square root of 3, that means it's a 30, 60, 90. So my job is going to be, okay, with x and y, which one's 30, which one's 60? That's right. And how'd you know that?
I looked at the picture and I figured it out.
Okay, well, we know the square root of 3 side is always going to be opposite of my 60. So when I'm looking at a picture, that means the side opposite of my square root of 3 is 60, which means the only other option then is for this guy to be 30. And then it's the same deal on letter B. I see the square root of 2, which means it's a 45, 45, 90. And then there's not much to think about at all because, well, 45 and 45 are interchangeable. That's basically what we're dealing with special rights. Excuse me. So, now I want to deal with some more of these on your worksheet. Make sure we've got this down. So let's go from here. Keep the note sheet handy though, so we can kind of interchange and use this. Oops, that's another nope. That's another one of these. That doesn't help me.
Okay, this is a good idea now. But you're understanding.
So here again, okay, this is the homework sheet for this. Okay, we're starting on a side where we're dealing with 45, 45, 90. And I even went so far is to kind of repeat on here what everything is, okay? Remember, when we're doing this, it's x square root of 2. And I even wrote on here how you would calculate each of those depending on what information that you have. So, when I dive into these, so let's say I dive into one like, I don't know, number 3. Okay, you're like, that's not even a triangle, it's a square. But the diagonal is cut it into 2 triangles. So here's what we're going to do. We're going to pay attention to the triangle where I have a value of a side, which is 18. So if I forget about this part, I go, ooh, 18 is a leg, which means this is also 18. What's the hypotenuse going to equal? 18 square root of 2, because it's just a leg times the square root of 2. I'm done. So as we're doing these, I've got to, again, help myself with the pattern to kind of see how this works. Now, when I get to 4, it's a little strange. I'm hoping we're going to see a pattern develop here. So I'm looking at this, I'm like, okay, so this is x, this is x. That normally is my x square root of 2 side. But there's no radical there. Ooh. I need to figure out what the plain old x value would be. So, I say, okay, what do I have to do to figure out what the x value is? Well, if I do this, thank you. What do I have to do to get x by itself? Divide by the square root of 2. Leg equals hypotenuse divided by the square root of 2. But again, I can't leave it that way. I can't leave it as 18 over the square root of 2. Mathematically not correct. So, we're going to fix it. We're going to fix it by multiplying by that square root of 2 over square root of 2. And just like when we did it on the notes one, okay, 18, not in radical jail. Can't multiply it with the 2. We're not intermingling with the jail folk. 2 times 2 is 4. Square root of 4 is 2. You're like, oh. 2 and 2. Oh, it just gets out of jail. Yeah. Can I reduce the 18 over 2? Yeah. 9 square root of 2. And that is my x value. So now here's a pattern I'm going to let you in on. Notice when you're dividing by the square root of 2, okay? What's 18 divided by 2?
No.
And slap a square root of 2 on it. That pattern works every time. So here's what I mean by that. If I were to give you another triangle and say x, x, 30. Those x values are 15 square root of 2. It's just half the hypotenuse, slap a square root of 2 on it. That's all you're doing. Okay? But again, you've got to get practice to where you recognize that to make it easier, because otherwise you're going to have to do this. Okay? Square root of 2, it's half. I'm going to show you another fun pattern here in a minute. But I'm trying to not leave you hanging on this stuff, as long as you're kind of thinking about it a bit. Now, I even threw a couple of, I guess we'll call them application problems. Okay. Sketch the figure that's described, then find the requested measure. Excuse me. The perimeter of a square is 48 meters. What's perimeter? The whole thing. We're adding up the sides. So, if the whole thing is 48, how do I figure out what one side is? Divide by 4. Now it kind of looks like number 3 did. Find the length of a diagonal. It actually sets up exactly like number 4 did. It just would be 12 square root of 2. So you kind of see how quick this goes if you actually give it a chance and think about it a little bit. Now, to me, the 45, 45, 90 is the easiest ones to deal with because it's just x, x, x squared root of 2. 30, 60, 90 is a little more complex. So that's where we're going to head next. We're going to head to the other side. So when we get over here, again, we've got all of our values listed in. Some help to figure out the other thing, but let's play with some patterns and see what we can do back here. So let's jump down. Let's jump down to number 6 because I got that one marked already. Let's see what I was thinking here. I want to find another one here in a minute, though, that does some of this. Oh, no, this is what I want. Okay. So this time, this is my side opposite 60. Oh, this is the one that's x square root of 3. Oh, this is kind of ugly like that last one we just did with the 45, 45, 90 because, okay, we can do this though. So if 8 equals x square root of 3, because that's my long side, what have I got to do to both sides again? Divide by the square root. And again, we're not real happy about this because we need to rationalize it. But again, I think, well, we'll see if we see the pattern here. We might have to do 2 of these to see the pattern this time, but we'll see. Because again, the square root of 3 and the square root of 3 just gets me 3. But I've got 8 square root of 3 over 3. I took that value I had, that long leg, and I divided it by 3. So here it comes. I'm looking to see if I've got another one on here that's going to make this more obvious. Oh, I see it.
Wait, so that's the answer?
That is the answer for my x. For my short side. Now for my long side, don't make this complicated. This is x. This is 2x. So I just multiply the 8 by 2. Notice it was just the 8. I didn't multiply this by 2. Okay, just the numerator value. Because when we're looking at the patterns on these, here's how my patterns work again. Okay, my 30 degree is x. My 60 degree is x square root of 3. And my 90, my hypotenuse, okay, is 2x. So here's where I got that from. Since my 60, okay, my long side was 8. And then we figured this all out and figured out that this is 8 square root of 3 over 3. 2x means I take 8 square root of 3 over 3 and I multiply it by 2. I can multiply the things together that aren't under the radical. And that's where the 16 came from. So I just take whatever this 30 is once I figure it out and I double it. So here's how that would work out for me. Let's say, for instance, because I'm trying to see if I've got more than one of these left on here, because I don't want to leave you guys with none. That would be bad. So let's say, I'm trying to find a place in the paper where we got room. Okay, we're going to move down and over. We're going to move to the upper right-hand corner here. So let's say I get a triangle. If you're not going to come to me going, I don't get your pattern, did you write the second one we did? No. Then I'm going to be like, because I'm going to have one come out that's a little more obvious in how this works. So let's say this is what I wanted you to do. Okay, I'm going to give you the long side. It's 15. You've got to figure out the other two. You're like, okay, I already know how this pattern works. It's going to end up this number times the square root of 3 over 3. I get it, because I know this does this, and I got to divide, and it looks like this. And I don't like this very much. Are you telling me there's going to be a pattern? Yes, I am. Because if I do the square root of 3 over 3, I get to here. And in a moment, it's going to be all clear, and you're going to be like, ooh, this assignment just got easy and fast. It's 5 square root of 3. Okay, this would be what my short side equals. And then my hypotenuse, I just multiply the 5 by 2. And I get it. But here's the pattern. 15 divided by what? 3 gets me to 5. Tack it on. You're like, wait a minute. When I did the 45, 45, 90, I just divided it by 2 and slapped the square root of 2 on it. So now you're telling me if I get to the situation here, I just divide it by 3 and slap the square root of 3 on it. Right, there's a pattern. So whenever you see a long side that you're going to have to do all of this stuff to, you just take that value, divide it by 3. Oh, it didn't go in nice. Okay, it's a fraction. And then multiply that by 2 to get to here. But again, if you have to do the math, it doesn't take us forever to do it. But if some of you are more pattern inclined, it's a way you can get to the answer. It's a way you can do it quick. So one more I want to hit up here. And then we'll see if there's any others you want to hit. And if there are, we'll do those too. Okay, number 11. The altitude of an equilateral triangle is 18 inches. Find the length of a side. Okay. What's an equilateral triangle mean? They all have equal sides. Now, that doesn't mean each of my sides are 6, because it didn't say each side is this or the perimeter. It said the altitude, which is the line that comes straight down, okay, from my vertex and is the midpoint of these other two sides. So here's what I've got to figure out from this. Okay, I've got a 90-degree angle. I need to figure out which one of those is the 60 and which one's the 30, because that makes a difference. Well, if you have an equilateral triangle, it means all your sides and all your angles are the same, which means each of these angles are 60, which means this cuts this 60-degree angle in half, which makes that 30. And now I have a triangle that I can work with to find my values. So I look at this and I go, okay, 30, 60, 90. Got this. Short side, long side, hypotenuse. I'm going to label them until I've got them in my brain. So this goes with 18 equals x times the square root of 3, because that's what my pattern tells me. So do you know what x is already? You should. But if you don't, we can calculate it. It's how the world runs. Because this is where, as I practice this and I see the pattern, you'd be able to do this entire problem in about 5 seconds. Because remember, once I get this cleaned up, and I'm hoping as you keep seeing this, the pattern is going to just stick in your brain. Remember, when it's a 30, 60, 90, if I have the long side like this, divide the number, the side you have, by 3. 18 divided by 3 is 6. Slap a square root of 3 on it. 6 square root of 3. 2x is 12 square root of 3, which is the length of an entire side of your triangle. That's my answer. I'm done. But if I know my pattern, I could have just looked at this and said, ooh, that's just going to be this divided by 3 square root of 3 times by 2. I'm done. Boom. But if you can't, that's your backup plan. There's always a backup plan for this stuff. Now again, how much this is going to click is going to be up to you. Suggestion: take a picture of the key, write down a few of the answers from the key if that's not an option for you, and sometime before your head hits the pillow tonight, try to do a few of these to reinforce it. If you stroll in here for our next class and you have not done any of that, it's going to be all completely gone. I'm just going to tell you. Because next time we get together, we're going to kind of go back over some applications plus some more of these before we get on to the more triggy type stuff, as I like to call it.